Good morning, everyone. Welcome to Tuesday morning at Chem 1211, General Chemistry at COD, with your host, me, Dr. White. Hi, everybody. All right, let me give you a game plan for today. First of all, I'll do an announcement or two. Then I'll go through Chapter 2 problem set, select the problems. If you want me to go through one, just ask. Next, I'll do a little lecture because next Monday we're going to have off for Labor Day. So I'm going to spend a little time with that. And then I'll go through today's lab. And on lab day, even though, don't tell anybody, syllabus says if we were face to face, we could go to 12 or 11:50. We won't. You'll be out of here well before 11. Well before 11, really. So that's today's game plan. All right, a couple of things. First of all, if you haven't ordered your chem kit from Carolina, you should be ordering your chem kit. Again, you don't need it today, but next week you will. So please order your chem kit. Another thing, yesterday, starting at 13:35 on the video that's posted for yesterday's lecture, I taught everybody how to use scientific notation on a calculator. I highly recommend, if you don't have one, purchase your calculator now and practice it. You should have done it for problem set 2 I'll go through, but you should practice. Remember the first day I talked about the video, or actually not the video, I just uh, showed my age, the Blu-ray, how to ride a bicycle. And if you didn't know how to ride a bicycle and all you did was watch that Blu-ray over and over again, what's going to happen when you get on a bicycle? Boop, you're going to fall off. I like that. Boop. But anyways, I liked it. And you don't want to go boop on a test. Do the practice problems on your own. Watching me do it, well, it's not that hard. Just like watching the Blu-ray. Almost said video again, Blu-ray. And I could have said VCR. None of you know what I'm talking about. But anyways, practice. Do the practice problems. I created them to help students. After test 1, you'll understand why I call them practice problems. Hint. So do the practice problems. When I do problems in a lecture, look at the video and you try them on your own and then look how it was done correctly. All right. Well, in that case, let's go to the practice problems. All right, thumbs up, people. Everybody see chapter 2 practice problems on your screen. Thank you, everyone. All right. Now, the first one is a skill you should have is write the following numbers in scientific notation. How do you do that? If there were a decimal point, you move it, and if they're not, you pretend there's one. You move it to the right of the first non-zero number. Again, move it to the right of the first non-zero number. You count the number of moves. And that will tell you what 10 to the x is. X is the number of moves. And if we look here, 1, 2, 3, 4, 5. That's why this is 10 to the 5th. If there's no decimals, trailing zeros are dropped. If there are no decimals, trailing zeros are dropped. So we move the decimal to the right of the first non-zero number, 6, then put 0.52. The trailing zeros are dropped because there's no decimal, and we moved it 5 times. That's how you get 6.52 times 10 to the 5th. We look at B, no decimal again, move it to the right of the first non-zero number. That's 3 moves. So it's 1.23 dropped to 0. And 1.23 times 10, what's x? 10 to the x, we moved it 3 times, is 3. Now that's for number 10 or greater. I will never put on a test, and really in real life, I never have scientific notation for a number that's 0 to 10. If you did, that's 10 to the 0 when it's 0 to 10, but that you don't have to know. Now, if you look at D, you'll see it's a number less than 1. Now you do the same thing when there is a decimal point, and you still move that to the right of the first non-zero number, 5. You have to move it 1, 2, 3. If there were any zeros trailing, guess what? You keep them because there's a decimal. Do I have an example of that? Well, I'll do one on my whiteboard. Now, when the number is less than 1, x, 10 to the x is a negative number. When the number is less than 1, 10 to the x is a negative number. We moved it 1, 2, 3 times, therefore it's 10 to the minus 3. Why don't you write this in scientific notation? 0.00005,610. Your turn. See what a nice guy I am? I share all the fun. When you're done, give me a thumbs up or turn on your webcam and smile. No, that didn't work. Nobody turned on their webcams. Dr. White's sad. And I'll give you another 10 seconds to finish. Then I'll do it. Got a clock up here that I can see the seconds. Got a clock up here that I can't see the seconds. All right, let's do this. How do you write this in scientific notation? You move the decimal point to the right of the first non-zero number. 1, 2, 3, 4, 5. Now, since there is a decimal point, we do not drop that 0. So we have 5 point, let me rewrite this. And then what is x? Well, when x is less than 1, remember it's times 10 to the x. When the number is less than 1, which this is, then x is minus. So it's minus 5. Oh, let's do another one. Here's another one for you to try. Write that in scientific notation. When you're done, give me a thumbs up. Use your emoji, or I like to rename it symboli. This makes more sense. It's a symbol, so I'll call it a symboli. See how creative I can be? I'll give you another 10 seconds to finish up. if we were in a classroom face to face when I do this, one, I can see when the students are done, and two, I tell them, when you're done, look up and smile. I have a bunch of happy, smiling students. All right, let's do it. This number is less than 1, but you still do the same thing. Move the decimal point to the right of the first non-zero number, 1, 2. Oh, by the way, lead zeros you drop. I didn't mention it up here, but I'll mention it here. Zeros after the first non-zero number, you don't drop. And we moved it 2 times. Remember, 10 to the x is negative when this number is less than 1. We moved it 2 times, and that's how you do it. And this is a skill you should have. And let's continue on. All right, now listen carefully. Dr. White's lazy, and I just was too lazy. Ignore number 2. I didn't go through with this, and in real life, you're not, in my class, you're never going to have to write a number in decimal from scientific. The other way you will have to do this, so ignore problem 2. But let's go to problem 3. And the question is, and this is a skill, hint, you should have. And that is how many significant figures are in the following numbers. If we look at A, all non-zero numbers are significant. Therefore, there's 1, 2, 3, 4, 5. That's how I got that answer. Now, zeros at the end without a decimal point are not significant. How you like that? No, they're not. And therefore, I have here non-zero numbers, 1, 2, 3 of them, a 0 at the end, no decimal. That's not significant. So there's 3 significant figures. Now, zeros that are between non-zero numbers are significant. So if we look at C, 1, 0, 1, the 0 is between 2 non-zero. The non-zero are significant, that's significant, and the number is 3. Lead zeros in E are never significant. And by the way, in D, they're all non-zero. 4, you do not use 10 to the x to figure out significant figures. That always stays the same. Now, E, lead zeros are never significant. Lead zeros, those in front of a number, are not significant. And this has 3 non-zero numbers. These are not, so it has 3 significant figures. Zeros at the end with a decimal point present are always significant. Zeros at the end with a decimal point are always significant. So if we look at F, we have 2 non-zero numbers. So that's 2 significant figures. Well, now we have a decimal point and 3 zeros at the end. So the answer is 5 significant figures. Now, G is a really tough one. We've got 3 non-zero numbers, but we also have 3 zeros. This 0 is confined between 2 non-zero numbers. It's significant. This 0 is between 2 non-zero numbers. It's significant. But this 0 is at the end, no decimal point, so it's not. So it'd be 1, 2, 3, 4, 5. Oh, I got it right. Yay. And that's how, well, let's do one for you. How many significant figures are in this number? Your turn. Thank you. And am I pronouncing it right? Is it Rochelle? Thank you, Rochelle. And I know Jasmine. And let's give Anna a little more time. Thank you. All right. So if there were a decimal, but there's not, we move it to the right of the first. Oh, wait, wrong one. Ah. All right. How many significant figures? All, and let me do something important. All non-zero numbers are significant. 3 zeros at the end, but no decimal. No decimal point. Therefore, they're not. So the answer here would be 3. And why don't you try this one? How many significant figures are in that number? Thank you, Rochelle. Thank you, Jasmine. Thank you, Anna. All right, let's see if you did it right. All right, all non-zero numbers are significant. That's 3. Ooh, there's zeros. Confined zeros are significant. That's 4. Zeros at the end with no decimal point are not. So 1, 2, 3, 4. There's 4 significant figures. Oh, let's do one more. These are fun to do. And here's one for you. How many significant figures are in this number? Thank you, Rochelle. Thank you, Jasmine. By the way, I'll remember, be patient. I always try and give everybody time to finish. All right, let's try this. All right, now lead zeros are never significant. Notice this number does have a decimal point. Non-zero numbers are significant, and zeros at the end are always significant when you have a decimal. So once again, lead zeros are not, non-zeros are, zeros at the end are, so that's 1, 2, 3, and the answer is 3 significant figures. And this is a skill you should have. And the question is why? Well, before we do that, let's talk about rounding off. Now, let's say you have a number that has a lot of significant figures. And for some reason, I picked 3 for these examples. You have to round it off to 3 significant figures. And how you do that, you keep the first 3 significant figures in a number. Lead zeros are never significant. And then the fourth one, if it's rounding off to three significant figures, if it's 4 or less and it's past the decimal, which is what's really going to happen in this class, you drop it. If it's 5 or more past the decimal, you drop that number and everything afterward, and the number in front you increase by 1. So let's look at 4a to round it off with three significant figures. You keep the 1, keep the 1, keep the 5. The second 5 I'll round off, that's 5 or higher. Drop that, increase that by 1, so it's 1.16. Now I have here B and C and D, ignore those. You won't do stuff like that. Now, if we look at E, how do we round that off to three significant figures? Keep the 3, keep the 3, keep the 5. I use the double squiggly line. I guess that's what you call it, squiggly line. And that's 5 or more. Drop that, increase the 5 by 1, and that's the correct number. And let me have you have some fun. Why don't you round off that number right here to 4 significant figures? Your turn. Thank you, Jasmine. Thank you, Rochelle. Remember, if you're having problem doing anything I'm talking about in class, always feel free to ask, either with chat, but once in a while I don't look down, so you may have to remind me, or turn on your microphone and ask your question. Because in my class, in my world, there's no such thing as a dumb question. All right, let's do this. We want to round it off to 4 significant figures. Keep the 1, keep the 2, keep the 7, keep the 4. That's my 4 significant figures. I'm using the 6 to round off. Is that 4 or less or 5 or higher? Hopefully I'll pick 5 or higher. I'm going to drop all that, increase that by 1, and that's the number you get. Oh, let's do another one. And why don't you round this number off to 2 significant figures? Thank you, Jasmine. I must give you a hard one here. Thank you, Rochelle. Thank you, Anna. All right, whoops, what did I just do there? I hit a down button. All right, when I went to pick this up, let's take a look at non-zero numbers you ignore in the front. This is the first significant figure. This is my second one. The one right after the second one, number 3 in this case, because you're going to round off the 2 significant figures you use to round off. And that number is at 4 or less, and the answer is yes. So I drop that and everything else, and that's the correct answer. And that's how you round off. And I have examples here how to do that. Now, let's look at mathematical operations. When you're dealing with significant figures, there's rules that govern how many significant figures your answer should be, depending on the numbers you multiply or divide, and later on add or subtract. Now, let's do multiplication and division. You get the same number of significant figures in your answer. Three more rings. It's not the Secretary General of the UN or the President of the United States, so I'm not going to answer it. Bluetooth phone. Thank you. All right. Now, when you multiply or divide, you get the same number of significant figures in your answer as the number you're multiplying or dividing that has the fewest significant figures. I'll say that again. When you're multiplying or dividing, you get the same number of significant figures in your answer as the number you're multiplying or dividing that has the fewest significant figures. And now when you do that, your calculator gives you a lot more significant figures than the correct answer. And if we look at A, we have 5.5 times 6.351. And I didn't have it in scientific notation, bad Dr. White, I should have, but 5.5 is 2 significant figures, 6.351, 4. Your answer should be 2, so you have to round this off to 2, keep the 3, keep the 4, to use the 9 to round off, drop that, increase the number in front by 1. Let's look at C. If we look at C, you have 3 significant figures, first number, second one, you put that in your calculator, it gives you this big number, and you have to round it off to what? You get the same number of significant figures in your answer as the number that has the fewest significant figures in your answer. In this case, both are 3 significant figures. Tea break. And your answer should have 3. So you round this off, keep the 6, keep the 0, keep the 5, use the 1 to round off as 4 or less, drop that and everything else, and this is the number. Now, one of your colleagues, oh, I'm so embarrassed. Oh. But anyways, even Dr. White makes mistakes. Boy, do I at times. But anyways, I try and keep them to a minimum. And here, E, I did make a mistake. 4, 6. I have this wrong. This should be 4 significant figures. I think I got this one right. There was one later on I missed. I'm trying to find it. Maybe I corrected it. But anyways, that's how you do it. Now, if we look at G, and these are things if you haven't done on your own, don't look at this video, go to the questions, try it, look at the video, or look at the answer for these questions. If we look at G, 1.22, 3 significant figures, 5.25, 3 significant figures. And this is the answer my calculator gives me. You might see 10 to the 0. If I moved our faces over, my face, remember, if you see 10 to the 0, that's equal to 1. Therefore, this number, you have to round off the 3 significant figures. Keep the 2, keep the 3, keep the 2. Use this 3 to round off. Oh, I forgot to put the squiggly line. And that's how you round it off to 3 significant figures. Now, addition, I'm not going to go through this right now. Why? Because it's going to be a number of weeks until we do addition. Well past the first test, you'll need it for test 2. And when we need addition, I'm going to come back and go through addition. But when you do addition, in this class, I don't think we do any subtraction. Not that there's anything wrong with subtraction. We just don't need it. But for addition or subtraction, you get the same number of significant figures to the right of the decimal as the number with the fewest. And with that, we're done with the practice problems. Remember, yes, you should practice on your own. Just don't watch me do it, because if you do, remember on the bicycle, if you don't practice, you go boop, you fall off. You don't want to go boop, fall off on test number 1. Pro tip, test number 1 always is the highest average. I mean, is. And therefore, that's the easiest test to get the most points of the 5 tests I'll be giving this semester. So right now, you should be studying hard, practicing, so you can get a lot of points, so you can get a good grade, because that will make you happy. And guess what? That will make Dr. White happy. I get happy when students succeed in my class. It gives me no joy whatsoever to see a student not succeed. So remember, do the practice problems. Any questions? Going once? Going twice? All right. What I like to do now for a while before we do the lab today, something I was going to start yesterday, but I think it was more important yesterday that I did my taught my method, how to eliminate test anxiety. If you missed it, and don't forget, I cut that out of the video. Ooh, don't I do that well? But anyways, I cut that out of the video because I don't want that floating around the internet for the rest of the time. But if you need to learn that method and you weren't on here in class yesterday, come to my office hours. Speaking about which office hours, today or tomorrow, I'll probably send out an email asking, I do my office hours now on Monday, Wednesday from 5 to 6:15. What would be a better time on Monday and Wednesday, late afternoon after 4, or before, say, 8:30 for most of you, if I were to change the hours of my office hours? Again, let's make it easier. Anytime after 4 on Monday and Wednesdays, what would be the best time? And don't put down midnight or 11. Nah, I like that. All right. Yesterday, we didn't have a chance to do it, but it's new chapter time. And that new chapter deals with atoms and elements. Yay, we're finally getting into some real chemistry. And now I am a happy camper. All right, when we talk about atoms and elements, the first thing to consider is the atom. And you should know the atom is the smallest particle of an element that retains all of the characteristics of that element. And it's time for Dr. White to be subtle. You should know what is an atom. And an atom is the smallest particle of an element that retains all the characteristics of that element. My gold ring here, if I could pull out an atom of gold, it has all the properties of gold. If I could pull out an atom of silver from something, I don't have any silver but on me or nearby, but if I did, that atom, and I couldn't hold it in my fingers, it's too small, has all the characteristics of that element. In case you were curious, the word atom comes from the Greek word atomos, meaning indivisible. You can't break an atom down to other smaller elements. So, what is an atom? The smallest particle of an element that retains the characteristics of that element. Now, how did chemists find out about this? Well, they went into the lab, did experiments, observed things, and came up with theories. And one of the great chemists of all time, an English chemist, Dalton, in 1808, that's only a couple hundred years ago in the history of mankind, that really isn't that long ago, came up with his atomic theory. Before then, they had all sorts of weird things going around in the 1600s, 1700s, like earth, wind, fire, and I forgot water, all sorts of magic, mist, and it was just hokey pokey stuff. But Dalton put chemists on the right road. And his theory, key parts was, and I'm not going to ever ask you this on a test, but it's good to know, every element is made up of tiny particles called atoms. And atoms of a given element are identical to one another and different from others. Now you look at this and say, duh, that's obvious. Well, back then it wasn't. This was earth shattering. I don't know about earth shattering. Hopefully the planet won't shatter, but it was quite significant, very significant. And the other things Dalton came up with is atoms of two or more different elements combined to form compounds. And a particular compound is always made up of the same type of atoms and the same number of atoms. And as I put on the board, I've talked about previously, oops, wrong color. Right color. Water, whether you're here in Chicagoland, if you go to, I don't know, Tokyo, if you go to Amsterdam, if you go to Mars, water, and that's really far from Chicagoland, off our planet, water is always two hydrogens, one oxygen, H2O. Wherever you go, that's what it is. And sodium chloride, table salt. Remember, please pass the nickel. Wherever you go, here, if you go to, I've been in Guadalajara. If you go to Toronto, been there. Now I'm thinking of cities. If you go to Brussels, been there. Well, I've been a lot of places. Salt is always the same, NaCl. And finally, a chemical reaction involves the rearrangement, separation, or combination of atoms. And this is very important. in a chemical reaction, atoms are never created or destroyed. That's called conservation of mass during a chemical reaction. When you react two compounds together, you do not create or destroy atoms. They're just connected differently to different atoms of different, from the molecules or whatever you're reacting. So that's Dalton's theory, atomic theory. And this was 1808. Now, when we talk about an atom, there are certain parts of an atom you should know. And these parts are called subatomic particles. Subatomic, what does that mean? Does everybody know what a submarine is? Give me a thumbs up if you know what a submarine is. And a submarine is a boat that goes sub, means under, marine, the sea. And no, I'm not going to start. How many of you have ever heard Yellow Submarine by the Beatles? Well, I see one of you. Go to YouTube, because I'm not going to ruin your days singing "We All Live." No, I have said I wouldn't do that. But it goes, "We all live in a yellow submarine." I won't ruin your day by singing it. It ruined my day too. But submarine goes under, submarine water, sub means under or less than, atoms. And what are those particles that make up the building block of all atoms? Here they are. But first, a subtle hint. Know this. All right, what are the subatomic particles? The first one are electrons. And you should know electrons possess or have a negative charge, which we show by a minus sign. Next is the protons. And the protons are subatomic particles that possess a positive charge. Protons have a positive charge. And finally, they're the neutrons. And neutrons are subatomic particles that have no charge. How many ever heard of the cartoon Jimmy Neutron? I see some of you have. If they had asked me to name it, I wouldn't do Jimmy Neutron. The exciting part of an atom are the electrons. I would have named them Jimmy Electron, because that's where you'll find out all the action is. Now, if we are face-to-face in a classroom, and I've done this, in fact, I did it in my 1211 last spring, where I had 48 students, and I said, everybody together, what are the three subatomic particles? I say, come on, with force. And everybody, and if you're at home now, you don't have to turn on your microphone, but do it with Dr. White. The first one, electrons. Second one, protons. Third one, neutrons. At this point, I'd say, come on, do it with feeling. Let's do it again. What are the subatomic particles? The first one, the electrons. Second, protons. And the final, neutrons. Again, you should know this. And you should know electrons have a negative charge, protons have a positive charge, and neutrons have no charge. And these are the three building blocks that make up all the elements in our universe. Mother Nature came up with a system whereby putting the electrons, protons, and neutrons together, different amounts, we have different elements. Gold has different amount of electrons, protons, neutrons than platinum, or than carbon, or than calcium. They're all made up, though, the atoms of electrons, protons, and neutrons. And you should know this. Now, where the heck are the electrons, protons, neutrons in an atom? Are they like just thrown into a bag and all together? No. Ooh, a bag of electrons, neutrons, and protons. That would be interesting. Not. But anyways, chemists went into the lab and did experiments. And the first one you should be familiar with is Thompson's cathode ray experiments. And this, if you've ever seen the old TV sets with the picture tube, those are cathode ray tubes. Electrons are going through a magnetic field and hitting a screen that has chemicals, phosphors, that light up different colors when they're hit with the different amounts of electrons. We don't use that anymore. Now we use LED or LCD screens like mine in front of me, my monitor. And by his experiments, Thompson was able to prove that electrons have a negative charge. So you should know Thompson's cathode ray experiments prove that electrons have a negative charge. What about the rest of the stuff? Well, where are the protons and neutrons? They're in the nucleus of an atom. And the nucleus is the center of the atom. And the nucleus, how did they find out about it? Well, Rutherford's gold foil experiments. If I look at the clock, guess what? It's time for a 5-minute break, and I've got a cliffhanger. You're just going to have to come back after our break to find out about the nucleus of an atom. I'll see you at 9:55, and we'll continue, and then we'll go a little longer. Then we'll do the lab, and we'll get out by 10:30 today. I'll see you in 5. Let's get going. All right, we're talking about atoms. And remember, atoms are made up of subatomic particles, which are the electrons, protons, and the neutrons. And where are the protons and neutrons? Well, they're in the nucleus. And you should know that the nucleus contains only protons and neutrons. Now, turns out the nucleus, which contains very small thing called the nucleus, contains protons and neutrons, are very dense. How did we find this out? By a great chemist, Rutherford. And he did his gold foil experiments. And let me do this. And let's go to the internet. All right, does everybody see on the right part of your screen, gold foil, detecting screen, alpha particle emitter? Give me a thumbs up if you can see it. Thank you, Anna. And this was Rutherford's gold foil experiment. And what's the experiment? You take very high energy particles, think of them like cannonballs, and you shoot them at a very thin foil, in this case, gold. Well, think of it, if you shot cannonballs at tissue paper, Kleenex, or Puffs, it's going to go boom right through it. Well, guess what? They did the experiment, and a lot of them went through, but some of them bounced back. That's what these red arrows. Think about it. If you shot a cannonball at tissue paper and it bounced back, you're going to say, what's going on? Now, let me tell you a little story. This is conjecture by Dr. White, but I think it's good conjecture. I was a graduate student. That's how I got my PhD. My advisor, Dr. William Roosh, who I will forever be grateful for, because working as his group, learning from him, laid the foundation for me to become the organic chemist I am, synthetic organic chemist. Well, when you're working in a research group as a graduate student under a professor, which Rutherford had graduate students doing those experiments, you go to your experiment or advisor and say, something different happened that's totally unexpected. And this happened to me too, not with that experiment, but things I was working on. And the first thing your advisor will say is, why don't you go back and repeat it once or twice? And you come back and say, I did it. I got the same really weird, strange results. And your advisor will say, all right, let me go out and watch you do it. And he'll look at it and say, you're right. He didn't have a beard, I do, but you're right. And then in this case, Rutherford had to come up with a theory. Why were these high energy particles, some of them bouncing right back? Again, that's like shooting a cannonball at, nope, I don't have any tissue paper, at it, and instead of ripping through like it should, it bounced back. And Rutherford came up with the concept, which is true now and has been proved by others again, that the nucleus of an atom is very dense. That's why it bounced these particles back. And it contains the protons and neutrons. Again, Rutherford's gold foil experiments, you should know, clarified, that's a fancy word meaning figured out, or cleared up, what is in the nucleus of an atom, and that is the protons and neutrons. Now, outside the atom, or outside the nucleus, are the electrons, and we'll talk more in this chapter and the next. Where are the electrons, which is quite important. Now, not to scare you, but if you look at your skin, it's made up of atoms of various elements, and you can't see it. Hold on. Nope, this doesn't work either. But there are atoms here, and the atoms in your skin are made up of electrons, neutrons, and protons. My wall here, where is it? Right here, the paint. That's made up of electrons, protons, neutrons, and atoms. Everything you see behind me is made up of atoms of elements which contain electrons, protons, and neutrons. Hope I didn't scare anybody, but that's that. As a chemist, when I look at things like this, I think about, wow, they are electrons, protons, neutrons held together in atoms. Now, instant replay time. Remember, an atom is the smallest particle of an element that retains the characteristics of that element. An atom is the smallest particle of an element that retains the characteristics of that element. When we talk about atoms, they're subatomic particles, and those are the small particles that are the building blocks from which all atoms are made. And as it says here, know this. Hold on. Everybody hear this when I do this? Did you hear that? Give me a thumbs up if you did. Thank you. Know this, and that is the subatomic particles that make up an atom are the electrons, protons, neutrons. You should know electrons have a negative charge. You should know protons have a positive charge, and you should know neutrons have no charge associated with them. I wouldn't have called them Jimmy Neutron, I'd call them Jimmy Electron, but that's a personal thing. And you should know Rutherford's gold foil experiments clarified the nucleus of an atom. The nucleus of an atom is the center of an atom, that you should know. And you should know the nucleus, which is very dense, contains only protons and neutrons. The nucleus, the center of an atom, has protons and neutrons, and outside of the nucleus is are the electrons. And with that, it's time for lab. I love these. I have 4 of them. The company that makes them, you can't see it, is a German company that's no longer in business. These are impossible, this quality. They never leave my house. I don't want to lose them. But anyways, it's lab time. Now, let's talk about lab. Lab, you'll be doing lab reports. Relax, they're not that hard when I do them. And they're always due the next Tuesday after the lab you've done it. So today is Tuesday. The lab you're going to do today is due next Tuesday. If it's late, I take off points. Labs are, I think 10 points in this class, or 11, but I think 10, whatever. It's in my syllabus. And they're easy points, but you got to hand it in. You don't hand in a lab, you get 0 points. That's 0. So hand in labs. since the pandemic, both online and face-to-face, which I taught last summer and last spring, a lot of students weren't handing in labs, even I'd reach out to them, hand in labs. And that caused, this summer, a couple students lost a whole letter grade because they didn't hand in labs. That shouldn't happen. So remember, hand in labs. Now, let's take a look. Does everybody see Blackboard on your screen where you see announcements? All right, thank you. All right, now, if you're on the main screen for our class, Chem 1211, net 03, look on the left and you see assignments. I'm going to click on that. Here are assignments. Now, before test number 1, you should download and upload this to here, the signature sheet. Now, I just realized I don't have here, sometime later today, I'll put in here the instructions how to upload from either a scanner, or if you don't have a scanner, how to use your cell phone to upload something here. Now, I have both as a PDF and as a Word document, the lab. You can download either one. Now, I have, and I'm going to open it up, I have the Word document. And you'll see the lab today, the safety lab. And notice I put in, please watch the videos in red. I'm not going to take time right now because it's a net course and you should be able to do it on your own. Watch the proper dress. And when you're doing the labs this semester in your home, you should always have safety goggles on, which are in your kit. You should always wear gloves. I wear the apron they give you. And here's another thing. Make sure you're dressed here. Don't wear shorts. I would always wear shoes, not open toe. And if you have long hair, have it tied back because you don't want it getting into chemicals. And you should wear a t-shirt or a long sleeve top, and that will protect you. Now, the videos here you should watch about safety equipment and behavior. Now, you're not going to use a Bunsen burner. I didn't see one in the kit. So still watch one of these on Bunsen burner safety if you ever do it again. Now, if you ever have an accident where you get chemicals on your arm or in your eyes, you should always flush it, and this is important, with cold or tepid water. Tepid is better. Don't do hot water. You'll hurt yourself more. And ideally, even though I don't think this kit, we had a kit which I told the students don't use that had a alcohol burner. No. But others instructors had them use it. I had people heat up water, not over the alcohol flame, but on your stove. Now, remember, things that are hot don't touch. It sounds like the obvious, but I've had students burn themselves in a lab when I said, don't touch this or whatever, it's going to be hot. And they still do. There's only so much you can do. Now, one important thing, if you're doing anything, and I think you are in glassware, things made of glass, laboratory glass, always check the container. Like if this were a beaker, check to make sure there are no cracks, check to make sure there are no stars. Again, when you're using any kind of glassware in a lab, always check that there are no cracks, investigate it, check that there are no stars. By the way, I have these personalized. All right, remember, when you're doing any of the labs, you should have on your goggles. I'll tell you a true story that happened to a colleague of mine when I was in grad school. In a research group across the hall was this postdoctoral fellow who I was friendly with, and he was doing a very dangerous reaction he had done at least 50 times before, where it was to make a certain chemical he needed for his research. And this one time, because he wanted to get to the symposium, he rushed, it blew up in his face. And I was across the hall, and I was one of the first ones in there to help him into the safety aisle. And then the paramedics took him to the hospital. I went there because I was close to him. I met his wife there, and we sat in the emergency room for 4 hours. The surgeons came out, and the lead surgeon came up to his wife. I was sitting next to him, and he said, "Your husband's very lucky." And said, "What?" Said, "If he hadn't been wearing his safety goggles, I'd be telling you now he's blind." And she was somewhat relieved. He did have, because the explosion was so forceful, the glass apparatus he was working on blew up, but luckily into tiny little pieces. The surgeon told us he had on his face over 400 stitches. Luckily, there are only 1 or 2. And 6 months later, he was very lucky, they healed. And that taught me a very important lesson. Up to then, I was wearing safety goggles in a lab when I worked, but I didn't think about it. After that experience, I always made sure my eyes were protected, and you should too. Nothing bad should happen, but you should always prepare for the worst, and the eyes, they can't replace. All right, now, important part of working with chemicals in the lab or in anywhere, even in your home, stuff you buy have ingredients, and those are chemicals. Even water is a chemical. All right, a couple of you said it's not visible. Let's see something. Oh, it's hidden. I'm sorry. I have the wrong date here.
So for this, we need to just watch it and like respond to you or something.
Do what?
For this lab number 1, do we need to just watch it or like?
You just need to, I'll explain it in a second. Let me just fix something real quick. No, hold on. Here's where I didn't change it. Well, all right, can you, everybody, check in the lab that it's now slab number 1, safety is visible to you?
Yeah.
All right. I changed one thing, but I didn't change the other. Oops, that happens. But anyways, now it's visible. I have to be more careful in the future. And thank you for saying that. All right, now, when you're dealing with a chemical, some chemicals are dangerous and some aren't, and some are really dangerous. How do you know that? Well, you know that by what we call either SDS, which stands for Safety Data Sheet, or MSDS, Material Safety Data Sheet. Please watch this YouTube on how to do that. Now, I'm going to go through some of this and then I'll show you what you need to know. You should watch this video on what these different pictograms mean. I think some of you have probably seen them on trucks that carry chemicals. Like this means it's an oxidizer that air can make it burn, or it can burn other things. The skull and crossbones tells you it's very dangerous, toxic. And here the flame tells you it's flammable. Now, when you look at the MSDS or SDS sheet, there's something very important called National Fire Protection Association diamond. And this is now optional, but most of them, newer ones, have this. It's also known as NFPA symbol. Now, there are different colors in the diamond. Blue is for health, red is for fire hazard, yellow is reactivity, and if there's some really special hazard, is white. And you'll see a number in there. The numbers go from 0 to 4. 4 is the most hazardous, 0 is the least hazardous, or no number at all. And if you notice in this example, the diamond blue is 3, which means that's a pretty hazardous material to your health, and that you should be familiar with. Now, a couple of things I do want to talk about. You should never eat or drink while you're working, doing the lab, because you can contaminate things with chemicals. And some of the things you should dilute and just run down your sink. And I'll talk about each of the further labs this semester, how to dispose properly of any of the chemicals you use or any of the equipment that's used. And after a lab, you should always wash your hands, even though you're wearing rubber gloves. You can always tell a chemist, especially an organic chemist, by if you see in the restroom an organic chemist, if they're in a chemical building or a lab, well, when they go to the restroom, they'll always wash their hands before and after they use the facilities in a restroom. Why? Because you might, even with gloves on, still have chemicals on your hand. And you don't want to get chemicals where you don't want to get chemicals ever. And I worked at one chemical company and we made very hazardous, really skin irritating chemicals, some of them. And one worker at the plant forgot to wash his hands before he went to the restroom. And he got chemicals where you never want to get chemicals. And he got some burns, chemical burns, where you never want to get chemicals. It took a while for him to heal, not pleasant thought. And it took a long while for the other workers in that plant from, how should I put this in politely, letting him know what an idiot he was. And he learned his lesson the hard way, or the unpleasant way. So always wash your hands when you're done with an experiment you'll be doing. I always do. Now, let's look at an MSDS sheet. Does everybody see safety data sheet on your screen right now? Thank you, Rochelle. All right, this is one you can find on the internet. All you have to do is put in the name of a chemical and then put in MSDS in Google. It'll take you to sites with different material safety data sheets. Now, I picked up this chemical I picked. It's called, one name is ethylene glycol monobutyl ether, another 2-butoxyethanol. And this is a key ingredient in a popular oven cleaner that I've used, and I've used on my sister's oven to clean it. But when I've used it, I've been very careful because I looked at the product, saw that chemical was the main one, and I looked up the MSDS sheet. Now, the MSDS sheet has changed over the last 30 years, modified somewhat different. The newer ones are a little different, but overall they're the same. I've worked at companies where I've invented chemicals, and I was asked to work with our safety people to write the MSDS sheet for chemicals I invented. And you always see the name, some synonyms, other names, and then they'll have different types of hazards. This one in section 2, you can see acute oral toxicity 4. This stuff's dangerous. And you scroll down, it has precautions. Notice, wash your hands after handling, don't eat or drink or smoke, things like this. A lot of these are boilerplate, is the same in all of them, but they're still important. Here, it'll show you the composition. For this, it's 100%. This wasn't the oven cleaner. General advice and important symptoms and physical data. What you should do if you accidentally spill some, how to handle it. And then here, TGA means, in case you don't know, total weight average. And that means exposure in an 8-hour period, you shouldn't have more than 25 parts per million. And these are different. OSHA is the Occupation Safety Health Act. And this is the minimum permissible exposure limit, PEL. And when you see something in ppm, you know, guess what? Be real careful. And when I use this oven cleaner, I open the windows in the kitchen and other part of the house, my sister's or mine. I make sure I have a fan in the door to help move air through, so I'm not exposed to a lot of it. Now, you scroll down, there are various things, and I'm trying to find something which I ran over. There we are. Hidden here, everybody see NFPA in the middle of your screen? Thank you, Rochelle, Jasmine. And in this lab, I'm going to be asking you to look up some MSDS sheets, and then looking at only the health. The higher the number, the more hazard it is. And 3 tells you it's pretty hazardous. 4 is really hazardous. And notice it's got a somewhat flammable. If we're up at 3 or 4, then I'd really be safety concerned. But this tells you it's somewhat hazardous. Now, when you download either the PDF or the Word document, you scroll down to page 5, you'll see Safety Lab Chem 1211, place for your name, and then some questions what is the most important safety equipment in your chemical kit, and why is it important? Answer that. What should you do if you get chemical? Go back and look at the video today. You don't know these answers. Same thing for 3. What does MSDS stand for? How do you find an MSDS? I've already gone through that. Go back and look at the video, which I'll post later today. Now, finally, for these chemicals, and look very carefully, I'm asking for what is the NFPA health rating for sodium hydroxide, sodium carbonate, and copper sulfate. And you do that like I did. You look at the MSDS and you got to scroll up and down and find NFPA. And I'm only asking for the health rating. And then of these 3, which is the most dangerous based on health rating? The one with the highest number. And that that's the lab write-up. This is due a week from this Tuesday. And if you want to hand it in earlier. Now, what I didn't have, and I'll post in the lab where you can download those files, I'll post a couple. You know something? Hang in there while this way I won't forget. All right. Does everybody see? And let me first of all submit this. Does everybody see lab 1, safety lab on your screen right now? All right, thank you, Anna. All right, you'll see now, I just put in there, thank you, Jasmine and Rochelle. You'll see instructions for submitting test and lab reports. I have both as a Word doc and a PDF. And if you do not own a scanner, there's a great app I found out from another instructor who found out from one of his students a while ago called Cam Scanner. And I have both how to use as a Word doc and a PDF. Do not spend any money for the one you purchase. Use the free version. Use the free version. You don't need to pay money to get bells and whistles that you'll never use in that app. And it's a free download for the free version, which is why it's called free. And that will allow you to take pictures with your cell phone and then convert them into PDF, which you can then upload that PDF to this section, the assignment section of Blackboard. And one important thing, and it's in my instructions, if you do not own a printer, or if your printer died and you haven't replaced it yet, you can write out the answers on a piece of paper, plain paper. Be sure to put your name. For question 1, just put the number. You don't have to rewrite the question. And then with your cell phone, you can take a picture. And that way you can upload it if you use Cam Scanner. And also, if you have Microsoft Word or Windows on your computer, I also explained how you can make a Word document, a PDF document, not Word, PDF, from your pictures and that too. But Can Scammer, a lot of students find it very easy. And that's today's lab. One last thing, let's do this before I leave you today. Let's go into student view. I'm now into student view. This is how you would see it. What you saw was mine, which I can make changes. Notice assignments. If I click on that, oh, good news. It's on there. And if you click on this blue part, lab 1, safety lab, here's where you can download. And then to submit something as a PDF, click on browse local files, pick the file, open, attach it, and then at the very bottom, let me get this out of the way, you'll see submit. And that's how you submit it. Again, attach the local file as a PDF file. Don't give me 5 different, you ever have 2 or 3 or 4 pages, especially on test? Well, tests we're doing face-to-face. So we're not doing it, you don't have to upload any tests. I used to, when we were during the pandemic, you'd also do this procedure for my tests. Hold on, I have a question. The first lab is this safety. You'll do no experiments for this lab. Who asked that question? Jasmine, does that answer your question? Thank you. And a thumbs up to you too. And the other, everybody else too. How about 2 thumbs up? And that's how you do it. You're welcome, Jasmine. And that's how you would submit a lab. Again, open up the lab, click on it. Notice it's due a week from today. It's 10 points. I was right on that. You have until the end of Tuesday, 4 p.m. roughly, to submit it. Answer those questions, scan it or take a picture with your cell phone and make it into PDF file with the instructions I give you right up here. You can use the Cam Scammer app if you want to with your cell phone. And don't buy the paid version, use the free version, and then hit submit. And with that, I'm done for today. Hopefully you enjoyed our get together today. Don't forget tomorrow on Wednesday, we'll have lecture. And with that, I'll say Gang Gesund, which is Yiddish for go in health. My grandmother, all great woman, Grandma Greenman, Bessie Greenman, greatest, probably the finest woman I ever met in my life, but a strong, powerful woman. She ran our family. She also ran the family business with my grandfather, but that's another story. I'll say Gang Gesund, goodbye. I stole that from Granny of the Beverly Hillbillies. I'll see you tomorrow. Bye now. Gang Gesund.